Good evening, everyone. Last class we started about John Dalton atomic theory. Before that, we started about atoms and molecules. We have studied about Maharshi Kannad. Good evening. If you say your name means I'll be able to understand. Is it Kanishk or Sam? Kanishk. Okay. Good evening, Kanishk. See, last class we were discussing about atoms and molecules, and in that section we have discussed, like, yes, good evening, child. So, in that section, what we have discussed, I'm just going to tell one thing. Like, whenever we are talking about atoms and molecules, we learned one thing, that is, atoms are indivisible. Indivisible means it cannot be further broken down. This was the concept given by the scientists or the philosophers that time they were present. So they told that we cannot be able to break down atoms. So that was their concept. Okay. Now, that concept was not true actually, because Anu and Parmanu means whatever content they have given, we came to know that after further discovery, we came to know that atoms are further broken down. That is, the subatomic particles are there. That is, the subatomic particles are electron, proton, and neutron. So the subatomic particles like electron, proton, and neutrons were exactly present. I hope you might have understood. So this concept we have studied, and in 1800th century, John Dalton, one of the very known scientists, he has exactly many questions. So see, whenever you are having some questions, means you will fall into some conclusions. Questions cannot be coming without any problem. Understood? So if any problem is coming, means automatically questions are coming. So John Dalton is having some different type of concept related to atoms. So he had many questions related to atoms. So further he started gaining answers. The answer was, he itself proposed some postulates, and he was exactly from not a very big rich family. He was from a weaver family, and he was exactly, his lifetime was totally dedicated towards study and knowledge. I hope you might have understood this one. So in that section, what he exactly talked about is atoms and its indivisibility. Okay. Atoms and its indivisibility means it will not be further broken down. So now look here, we were talking about, we already talked about this sections. Kanish, class till where we have discussed, I think we went to the postulates. Come on, we went to the postulates. In the postulate section, we have discussed about the postulates of atom, what John Dalton has given. We already discussed, and we talked about law of conservation of mass. And after understanding the law of conservation of mass, we studied the law of constant proportion also. So these two things we have studied, like atom can neither be created nor be destroyed. So in any chemical reaction, I have given the example of making a cup of tea. In that, we have learned a very important thing, that like when we make a cup of tea, means once the reaction is proceeded, we cannot revert it back. That was one of the chemical reaction. So when some chemical reactions are done, the chemical reactions will not be returned back. Okay, so that means once we make a cup of tea, means the cup of tea will not be getting converted into milk, sugar, and tea. We cannot get it back. That's exactly the process of chemical reaction. I hope you might have understood this one. And in that law of conservation of mass, we have studied what was the law of conservation of mass. Says that the reactant amount will be equal to product. The mass of reactant amount will be equal to mass of product. That's what we have studied. Okay. And after that, we have solved one question, ratio related questions also we have solved. And then some questions we have done, constant proportion, fixed proportion part, we have finished it out. And we had to discuss some of the most important things. Law of reciprocal and law of multiple proportion is not in your syllabus, so we need not to do that. Postulates we fit in. So we were talking about the postulate, the Jordan Delta. See, it's like, you understand, someone first time understanding atom, so that is their own observation. So if somebody will be talking about atom and they will be talking about what in all are the properties of atom and what in all are the content related to atom, that's his own perception, but this perception fit in into some of the concepts very nicely. Okay, so some of the concepts we cannot ignore. See, this was the most previous section content which we cannot ignore first, understood? So it is exactly fitting nicely into the content. So some parts are there which we cannot ignore, and we have to appreciate the work what he has provided to us. So the first important thing what he has given, maybe right now, Unnati, good evening Unnati. So maybe right now we cannot be able to accept that part, but 100% it is logical. See, that time nothing was there, no lab was there, no sophisticated machine was there, but then too his content was fitting into the target. Okay, so what was the content? What was the content here? Element consists of small indivisible particle called atoms. What he said that elements are exactly consisting of small indivisible particle. What is the meaning of indivisible? Indivisible means which cannot be further broken down. An atom takes part in chemical reaction. That was his concept. Okay, his concept is very much accepted, but only one problem was there. He said that atom cannot be further broken down. That we have changed. Okay, we changed and we said that atom can be further broken down into subatomic particles. Means we can break the atom into subatomic particle. Yes, Sham, Yuvashri, Bhavya, Arunisha. Yes, actually right now Kanishk is present and Chahil is present. So that means what? Atom can be further broken down. Atom can be further broken down, and subatomic particles will be exactly there. There only one small thing change has been done. Other than that, this is well accepted. Element consists of small indivisible. Element consists of atoms. If he might have written that, it is accepted. Element consists of atoms, understood? And these atoms are taking part in chemical reaction. That's correct. If we might have wrote at element consists of atoms. So every element is consisting of atom. Today we are going to understand this in much details. Okay. So now look here. Wait 1 minute. So look here. Today we are going to understand in much details how it is exactly. So like if I'm going to talk about If I'm going to talk about hydrogen, hydrogen atomic number is 1. So here it is exactly, we are going to talk about hydrogen element. So this is element. Hydrogen is an element, its atomic mass is 2, atomic number is 1. So when we are going to talk about it, so only its outer nucleus, only one electron is present. So this is atom. So element is made with atom, okay? But the atom structure is not same with that of the another atom. So if somebody will talk about helium, helium, its atomic number is 2, mass is 4. But we are going to talk about atomic number. So in the outermost orbit, 2 electrons are there. So 100% outermost orbit, 2 electrons are present here. That means here it is 1 electron present, and here it is 2 electrons are present. So that means what? Both are atoms, but they are not same. So commonly we will call it as atom. Just like understand one thing, when we talk about atoms, we talk about not similar type of atoms, different type in general. So like if I will say that 1 dozen egg, 1 dozen egg, 1 dozen pencil. So 1 dozen contains 12. Understood? Dozen is consisting of 12. So that dozen, 1 dozen egg means 12. 1 dozen egg means 12 pencil, 12 egg, 12 oranges, 12 banana, whatever is there. But in 1 dozen, 12 is there. So in the same way, when somebody will talk about element, element is made with atoms. These atoms are not same. These atoms, by structure wise, it's not same. Here in this structure, hydrogen only 1 is there, helium it is 2. Where we are going to talk about chlorine, chlorine structure will be exactly having Chlorine structure will be exactly having 2, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7. So that means what? Chlorine structure will be having what? Chlorine structure. See, all the three elements, what? Chlorine, hydrogen, helium, all are made with what? All are exactly element, and they are made with atoms, but all the atomic structure, the general word what we are using is atom, and the atoms are not same. So this is the one of the most important thing we had learned here. I hope everybody understood this one. Chahil, Kanish, I hope you might have understood. So this is one of the concept we learned about element, and the concept we learned about atoms. Understood? See, the atoms are making the element, but the atoms of different elements are not same. The atoms of different elements are different. Like hydrogen, chlorine atom, and hydrogen atom and helium atom, they are all atom, but they are different for different elements. So this is exactly the most important thing we had learned. Understood? So now we'll go back to our work, please. So element consists of small indivisible. So we are going to erase the word indivisible because individual was the only mistake. It can be further broken down. That's the new content we have learned. Now atoms of same element are alike in all respect, and that's the true answer. That's correct. So he's see whatever his concepts were. Some of the concepts we have revived, but some of the concepts we are going to take. Like atoms of same element are alike in all respect. So atoms of same element are alike in all respect means what? Atoms of same element, like we are going to talk about hydrogen. So I took a container, in that I am going to take hydrogen. So when I am going to take hydrogen in a container, in that container, how many hydrogen atoms will be there? All will be looking same because it is coming from same element. So since it is coming from same element, it will be looking same. So like sugar, what is the glucose? We can take glucose. So C6H12O6. So glucose part is there. Understood? Because glucose and sugar, they both are two different things. One is a simple sugar, simple carbohydrate, one is a complex carbohydrate. Understood? So C12H22O11. C12H22O11, that is C12H22O11. This is the formula of complex sugar, and this is the formula of glucose. Understood? So glucose is very easily digested. It is for energy giving, but complex sugar is not that. Complex sugar is full of fats. Okay. So this is the difference between glucose and complex sugar. But when you will be taking a container of sugar, you will always find sugar molecule, same type of sugar molecule, same physical property, same chemical property. So same way, if in a container we are taking hydrogen, means we will always be taking hydrogen, same type of hydrogen molecules we are going to get. I hope you might have understood. Hmm? Hey, sleeping monsters, reply yaar. As if I'm feeling I'm talking to myself only. What's that? Yes, yeah. So element consists of small indivisible particles, and they are, see, so same elements are same. Atoms of different element is different. That's also we know. Atoms of like sugar and salt. I cannot be saying that sugar and salt is same because chemical composition sugar formula C12H22O11 and salt is NaCl. Salt is what? NaCl. So chemical formula of salt and sugar is different, their taste is different, texture is different, crystalline structure is different, so everything is different. So definitely they are made with different type of elements, so the compound will be different. So but if you talk about element of hydrogen and chlorine, just now I showed hydrogen and chlorine are not same. So this is exactly the second property. By luck, not by luck, by his hard work. Actually, he was the one who has derived this much important concepts. We cannot say that all his concepts were wrong. We can say that he tried his level best that time, because that time resource were very less, and with a very less resource he has done so much good work. So atoms cannot be created nor destroyed. Yes, in the entire universe whatever is generated we cannot destroy it. It can only change its state from one form to another. If we are burning something, the energy will get converted into gaseous molecule or what you called another heat. But the system remains the same. So in the system, whatever energy content will be there, the energy will keep on transferring. So that's exactly the content of atom. We cannot be creating anything. We cannot be destroying anything. It can only change its state. Okay. So that's the next concept, and that is also very, very true what he said. Atom combines in a fixed small whole number ratio to form molecules. That also is one of the most important thing. Like, just what does this means? Property number 5. If you hear property number 5, it is most important property. Sorry, property number 5. So if I'm talking about property number 5, atom combine in a fixed small whole number ratio. Atom combine in a fixed small whole number ratio. What is the meaning of fixed small whole number ratio? Means the statement sounds very nice, but what is the meaning of this statement? So first we are going to know what does the meaning of this statement. Atom combines with a fixed small number ratio. What does this means here is, see, I'm taking hydrogen and I'm taking oxygen. Okay, I can write anything, but when water molecule is coming, water molecule will always be, I can write anything now. I can write H2O2 for water molecule. I can write HO, I can write H2O. But why water molecule is only H2O? You understand this one very nicely. Understand, wherever whatever is fixed, it is fixed, it cannot be changed. Understood? So that is the fixed ratio, fixed proportion. So if I'm talking about hydrogen peroxide, hydrogen peroxide cannot be used as water, but water is used, and water cannot be used as hydrogen peroxide. So where what is needed, that is needed. Understood? So when water molecule is there, when we talk about water molecule proportion is fixed, H2O, and this is small fixed whole number ratio. Okay, so small fixed whole number ratio it is. So the ratio is exactly considered as 2:1. That's about atom I'm talking about. Atomic wise, the ratio is coming as 2:1. Atomic wise, the ratio is coming as 2:1. I hope you might have understood. So atom wise, the ratio is coming as 2:1, but atomic mass wise, the ratio is coming as 1:8. And last class we have discussed about it. So definitely when we are understanding some of the content, we need to understand some very, very important points. And in that point, it is exactly one of the thing is when we make some compound, the compound is made in smallest fixed ratio, but whole number ratio we cannot write there 2.5, 3.6 like that. So some of the content I'm teaching you, please pay attention here. Positive, what you call positive ion and negative ion, I'll teach you positive and negative ion. But first you understand here, this is sodium and this is chlorine. Sodium is +1 and chlorine is -1. By crisscross rule, it will take NaCl. So see, small whole number ratio it has taken. It is not making sums. So this is salt. This is salt with a very small proportion it has taken. Now water molecule, if I'm forming, say water molecule I'm taking its +1, and here it is exactly, but how many oxygen is exactly having? Oxidation -2 is there. So it will exactly do like this. So it is coming as H2O. This property, this rules I'm going to teach you. Don't worry about it. So just for promo, I'm showing you how it is exactly going to be. So water molecule and what you call sodium chloride, they are always present in a fixed proportion. Understood? And their proportion will not be changing. The whole number content will not be changing. That's the most important point. Okay. Tube lights, you understood or not? No tube light is glowing today. I am only standing here. Where are the rest of the idiots? Chahil, understood or not? Any doubt is there? Yes, understood. Good. So you should be saying me that I understood, not understood. Any point doubt is there, because this is one of the basic structure of chemical chemistry. See, chemistry, entire chemistry based on compounds only. Understood? Their reactions, their procedure of reactions, what in all content related to it. So this is the main structure of chemistry, we can say. Atom is the most important part. We cannot deny the, see, what is not, that's the most important thing. There also exist. Understood? And that is, so chemistry, we are exactly, we can't be seeing, we just, but when we are heating it, it is making a cup of tea, and milk and tea taste totally different. So that's one of the example which is saying that the chemical reaction is exactly existing everywhere. Understood? In our body, what food we are eating, that also is doing chemical reaction. The biocatalytic enzymes that is present in our body, it digests that food particles and convert it into different energy form. So whatever is there, there is always a form. Understood? So chemical reactions not only taking place in our body, chemical reaction is one of the bases that is taking place everywhere. I hope you might have understood this one. So atom combine in a small whole number ratio to form molecule. This also we have discussed. So these are only some things. Now you tell me where you found mistake. See, this 5 postulate he has given. In this 5 postulate, which section you feel you need to change? Okay, which section you felt that you need to change? First section, only one small word, and that is atoms are indivisible. Indivisible means which cannot be further broken down, because right now itself I have broken it into subatomic particles like nucleus, neutron and proton is there, and extra nuclear part, electrons were there. So just seriously I just broke it into subatomic particles. Rather than that, all the contents are well accepted. I hope everybody understood this one. Come on, say. Today network is slow or I am fast? Yes, super. But can I shout? Give me permission to shout. I'm in live class, but I'm seriously feeling very angry. Rest of the students, better I will use nice words for them. Oh, Tanisha will not be able to join today. Her mother messaged me. She is outside today. But what about Yuvashri? What about Aru? Okay, come on, we'll get back to work. Merits and demerits. So definitely everything is having good points and everything is having bad points also. Something which is good first we are going to talk about, then we will talk about the bad things. Okay. So Dalton theory explains the law of conservation of mass and law of constant proportion. Yes, see, these are the two important laws still we are holding. What are the two important laws? Law of conservation of mass, which can never be denied. Entire universe, anywhere you will go, these two laws are accepted. Understood? That is law of conservation of mass and law of constant proportion. And his theory, what theory, five postulate he has given, in that two postulates explains conservation also and constant proportion also. That point 4, if you see very closely, point 4 is explaining this one. Which point is explaining? Point 4 is explaining this one. Point 4, we will go point 4. So point 4 of his postulate is explaining law of conservation of mass. What is the law of conservation of mass? The law of conservation of mass says that matter can never be, mass can neither be created nor be destroyed, and we know that what is the mass in the reactant side will be equal to mass in the product side. So that's the law of conservation of mass. What is that? Law of conservation of mass. Understood? That is amount of mass in reactant side is equal to amount of mass in product side, and it is nicely fitting his postulate. Postulate number 4 and his postulate number 4 and law of conservation of mass, they are nicely fitting in. So 100% it is correct. Now law of constant proportion and point number 5, that is everything is exactly joining in a fixed proportion, this in whole number. So these two postulates what he have given long back, his content and these two conservation properties are nicely matching with each other. That's the most important remarkable discovery, and at the most important remarkable point postulates he has given. Okay, now atoms of element take part in chemical reaction. It is still true today, 100%, because see, that's what I told you now, that atoms are the one who is taking part in chemical reaction. Who said this first? Dalton was the one who said it first. So we should say hats off to you, boss. You have told absolutely correct point. So by science means we can be definitely appreciating this man. He had not that much sources. That time he had no source to that much to prove that point, but yet he had proved some of the point which was still taken by science, which was specifically this chemistry community is exactly going to take this with wholeheartedness, because still it is true. So chemical reactions, whenever we are talking today, it is exactly involving atom. So elements are having atom, and atoms are taking part in chemical reaction. This is what he said, and that point is still true. That's the most important thing. Now demerit list is so high. 2 merits are there, 5 demerits are there. So a person who is having 2 merits, they are overshadowing by 5 demerits. See, understand that time what and all demerits were there that he had not seen. So that's what I am always telling, that if you have demerit means first you take care of your demerit, merits will be highlighted nicely. So now look here, the atom is no longer supposed to be indivisible, which why I kept on telling that atoms are having subatomic particles. What and all are the subatomic particles? Electron, proton and neutron are the subatomic particles. Electron, proton and neutron are the subatomic particles that is exactly present. That is exactly present. So atoms are having electron, proton and neutron present in atom, but he told that atom cannot be further broken down. That was his first problem. Understood? But this much good points are there. Now next, he could not explain why do atom of same element combine with each other. Yes, he was talking about atoms of different element combining together, but he did not explain atoms of same element combining together. That's something which he has overseen. He has not talked about it. So what does this mean? See, he explained about this. He explained that different type of elements are joining together in fixed proportion, but he was not able to explain about this. So if chlorine and chlorine I will keep now, they will itself combine together and they will make Cl2. That is called as homogeneous diatomic molecule. Homogeneous diatomic molecule means this is heterogeneous diatomic molecule. Heterogeneous diatomic molecules, it is containing two different elements. Two different is hetero, same is homo. Homo means coming from the same family, coming from the same element. So here these two chlorine is coming from the same family. Since the two chlorine is coming from the same family, it is called as homogeneous diatomic molecule. But this is exactly called as heterogeneous diatomic molecule because one is nitrogen and one is chlorine. I hope you might have understood this one. I rest my case. So this is exactly chlorine. That means homogeneous diatomic molecule, and this is heterogeneous diatomic molecule. Diatomic is common word I am using because here atoms are taken from two different elements. There atoms are taken from same element. Understood? But Dalton explained about this one, but he did not explain about this one. Same he did not explain, different he explained. So what was his mistake? What was people mistake? His mistake is not anything. I don't believe that he has done something big crime. But it is coming as a demerit only because he talked about different element combining together. He did not talked about same element combining together. We can take it as a defect, but it's not defect. It's like he did not mention that part. Understood? So as a intelligent people, you will take it like fine. He did not have time to explain this part, but definitely his content was correct only. Different element combining he explained, same element combining he did not explain. So that was his mistake. So it became his drawback. Okay. Now the next important drawback was isotopes. Where he failed was isotope. Let me check isotope of hydrogen. So here hydrogen. Yeah. Okay. So here isotope of hydrogen is exactly having three isotopes. Okay. So here atomic number of the isotope is same. You see 1 1 1 1. Atomic number is same, but number varying. So if its mass number is varying, then 100% its capacity to combine also will change. Understood? Its capacity to combine also will change. So Dalton did not explain about chemical reactions of isotopes. He talked about the chemical reactions, but he did not talked about the chemical reactions of normal element. That was the thing he has overlooked. Good evening. So he has overlooked. So there are atoms of same element may not necessarily be identified in all aspects. So there are number of elements whose atoms possess different masses. All these elements of same are, all these elements are exactly same. That's the most important thing. Good evening. So here exactly atomic number but different mass number, and they are called as isotopes. Okay. So three isotopes of hydrogen are there. Three isotopes of hydrogen are present here, and these three isotopes of hydrogen are exactly what you call, they will combine also differently. They'll combine also differently. Okay, fine. I hope you might have understood this one. Okay, fine, no problem. So atoms of different element may not necessarily be different in all aspects. That's also means sometimes the elements are different, but their properties are same. So there are number of element whose atomic number is same, different, but mass number is same. So all these atoms like we are going to talk about calcium and that is argon. So if we are going to talk about calcium and argon, what is happening? Their atomic number is different, but mass number is same. Understood? So they are called as isobar. So that also will be exactly creating a little variation in reactions. So variation in reactions are also because of either isotopes or isobars. So in simple way, what you are going to write here is his four major defects I am telling you. Okay. So first major defect is, I'm just going to tell you, you just remember that one. This much description is not needed. Just simple thing, simple content. You need to understand what was his mistake. First mistake what he did was not his mistake also. It's defect. It's demerit. Demerit means when you have some you said something and that point is not accepted, it's demerit. Like that you say he was a big person. So big people answers are not coming as mistake. It is exactly defect or whatever you want to say. Just one second. Fine. Yeah, I'm all right. I'm perfectly all right. So now where I was, so we need to talk about the defects, whatever defect was there. See, first merits and demerits. We are going to talk about the merits and demerits. What is the merits and what is the demerit? First, his postulate number 4 was explaining, postulate number 4, that is atom can neither be created nor be destroyed. It was explaining law of conservation of mass. His postulate number 5, that means all the elements are exactly combining in a fixed proportion by mass in whole number to make compound. That is explaining, the postulate number 5 was explaining law of constant proportion. It is explaining what? Law of constant proportion. So this was his portion. This was his merit. Okay, fine. So this is exactly coming its merit. First is, he said, okay. So here, when we are talking about defect, we need to check one thing. First point, one we are going to talk about, he told atoms are indivisible. That is not possible. Atoms are indivisible. Indivisible means further broken down. This was problem. Atoms are not indivisible. It can be further broken down. Okay. Second property, it was exactly about what? He told atoms of different element combined. Different elements combined. He talked about different element, but he did not mention about same element can also combine. Same element combining, same element can combine, like hydrogen hydrogen, chlorine chlorine, like this. So the same elements can also combine. hydrogen, hydrogen, chlorine, chlorine, like that combination he did not explain. He explained this one, like sodium and chlorine combining, other things combining, but he did not explain about this one. So this was missing. This was missing in his postulate. Then he did not talked about isotopes. He did not talked about isotopes. He did not talked about isobars in chemical reaction. Isotopes means same atomic number. Hi Smriti. So a same atomic number but different mass number. So same atomic number plus different mass number also reaction will vary. And next one was calcium and argon. Here 20, so their mass number is same, atomic number different but mass number is same. That also he did not explain. So these were the four major defects. If you are very intelligent, please kindly note down this one. In very shortest way I have explained the entire scenario. I have just merged in a very simple format. If you keep this means you need not to mug up those things. Fourth postulate explains law of conservation of mass. Fifth postulate explains law of constant proportion. Bingo. Defect, he told atoms are indivisible, but atoms can be further broken down into subatomic particles. That was the first thing. Second, different element combined, but actually same element can also combine. So he missed this point, that same element can also combine. Next, isotopes in chemical reaction he did not mention. Isobars also he did not mention. So that was not very big thing. Because of that we can hang him. It was not exactly like that type of crime, but yes, he missed. Fine. I hope you might have understood. So this was the defect and this was the demerit and this is the merit. I can answer your question very well, but I am not answering. You know one thing, for you I am going to tell only one shot. I will finish the entire word what you have said. But I'll say one thing only to you because you compelled me to say something. So I'm saying you, no matter what is good or bad, you listen. No matter what is good or bad, let me, 1 minute, lovely. No matter what is good or bad, I'll do that. But only one thing, I need to answer one person. No matter what is good or bad, our duty as a teacher, as a mentor, we always treat the student in the same format. And we never want our children to go in a bad track. It's humanity. Yeah, that's what. Because he compelled me to speak, so I opened my mouth. They will drink and they will do bad work is their duty. That is their thing. So we cannot be changing it. But our duty is to teach and to treat equal and to let them understand equally. That's the most important prior duty. One person can change the world. Yes, you can listen this class. 100%. You both can listen the class. The thing here is the class is related to studies. It is not waste. I'm not wasting one single minute of your life. I'm teaching something very fruitful. That's the first thing I'm doing. I'm not standing here for unwanted things. I'm standing here purely for teaching. And third, second important point is if you listen me, you will learn. Okay. And the third thing is a good person will always teach best, not unwanted things. So I'm not teaching anyone to drink or do alcohol or do unwanted things. I'm teaching here what is the meaning of chemistry. Understood? So good things, if you really open my mouth means I'll speak something. That's the concept what they're thinking. But yes, definitely we need to let them understand. Let them understand. मन के सच्चे होते whatever, but definitely we people are not trying any one of our student to go in wrong track. We want everyone to go in good track. If you are good means you will change everything for good, not for bad. Okay. That type people should learn. Do one thing, one day, one good work you do for one person, next day you will change. No, Himanshu, I'm not ignoring anyone. I just told him that this is exactly not good. Okay, just I got little carried by words. So, rest other is everything fine here. So, we are going to talk about the next part, please. Atoms. We are going to start about atoms. I have removed mole concept. I can teach and I can keep a special class for basic concept because mole concept is one of the most important basis for grade 11 and understanding is the quantity. Understood? And the entire mole concept, Avogadro number, is a very important topic. Yes. No, it's not like that. It's not like that. Some network issue might be there. Now look at atoms we are going to talk about. So if somebody will be talking about atom is the smallest. Lag uncle is coming. Cyclone uncle is coming, so I don't know. Some network issue might be there. But from my side, everything is all right. Yeah, all right. So now look here. An atom is the smallest particle of an element that take part in chemical reaction. So we need to understand one thing. So atoms are what? The smallest particle of an element that is taking part in chemical reaction and it maintains its chemical identity throughout the chemical, throughout. Nice. That's a nice answer. Whatever. So I'm going to talk about atoms. See, listen. Now I'm not going to get distracted. So now listen first. So one we are going to talk about atom. We are now specifically going to talk about atoms and its atomic composition. So it is the smallest element. Sorry, it is the smallest particle of element. It is the smallest particle of element that is taking part in chemical reaction, and it is not going to change its identity. Last class I was discussing about atoms and I'm going to talk about it. So get back to the work, please. So if somebody will be talking about atoms, just try and understand this one. Yes, it's a good chapter. So please kindly understand one thing. So in a chemical reaction, if I'm going to talk about sodium and chlorine, let's see like a layman, like we don't understand one thing. Anything about chemistry we are not understanding, but if you will understand this part, you will understand the entire story. See, all the element in the periodic table, they want to become like 18th group. Okay. So definitely in the periodic table, 18 groups are there. How many groups are there? 18 groups are there. Just understand this story. This is S block, this is D block, and this is P block. So here in P block, so total how many are there? 18 groups are there. The last group is exactly called as noble gas group. Understood? And they are exactly called as the stable people. Hi Anvi. So they are exactly called as stable. They are stable. Understood? So they are the most stable gases. Understood? So now what we are doing here is group 18. Now all the other element of the periodic table, because they are stable, they want to gain the stability of that. So everyone you need to understand. So I'm fine and we. So now you need to understand that total 18 groups are there. Out of that 17 groups are wanting to become like 18 noble gas. Understood? So what they do is they either gain electron or they lose electron to become like 18th group. That is the noble gas. Understood? So these family are exactly called as stable family. So it's just like one simple example I'm giving you. One richest person of the India, you want to become like them. Every day you are thinking, if you're a business person, means your main focus is I want to become like that. Okay. So now next important point is if somebody will be asking you whom is your idol, so definitely one big person who can do something big, you are exactly making that person as idol. I hope you might have understood. So that means one mentor is there and you want to become like that person. So that's exactly the concept of noble gas. So all the other element of the periodic table, they want to gain the nearest noble gas configuration. What is the word? Nearest noble gas configuration. Nearest noble gas configuration. So all the other element of the periodic table, they want to attend the nearest noble gas configuration. So for this story, in sodium, what is the problem is its atomic number is 11. So it's having 2 in the first orbit, 8, 1, 2, 3, 4, 5, 6, 7, 8 in the second orbit, and 2, 8, 1. 1 in the third orbit. Okay. So sodium is exactly very near to whom? Helium, neon, argon. So sodium wants to become like neon. To become like neon, neon structure is what? Neon structure is 2, 8. So neon is stable 4, 5, 6, 7, 8. But sodium is having one extra. So what sodium will do? Sodium will leave its one electron to become like neon, because everyone wants stability in life. So here the elements also, the atoms of the element also want like that. So what sodium will do? Sodium will leave its one electron. So what is the story here? Sodium will leave its one electron. How sodium will leave its one electron? It will release its one electron and it will become free of that electron. The moment sodium will leave its one electron, it will become like neon, very good, stable. So once it is losing one electron, it is becoming stable like neon. Same story goes with chlorine. So chlorine is somewhere very far and chlorine wants to become also stable. In chlorine, what is there? 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then outermost orbit 1, 2, 3, 4, 5, 6, 7 is there. And chlorine wants to become like argon, because chlorine is having, if I am checking chlorine, argon structure is this one. 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So chlorine ideal is argon. So chlorine wants to become like argon and sodium wants to become like neon. So for that, what they are doing is, one is leaving one electron and one is accepting one electron. So if this chlorine will get one electron, if this chlorine will get one electron, it will become like argon. If this sodium will give this one electron, it will become like neon, because both want to attend the nearest noble gas configuration. Understood? So now what they are going to do? So they both want to become like someone else. Understood? So for that case, what they are going to do? Sodium will release its one electron and chlorine will gain one electron. Bingo. One is releasing electron and one is gaining electron. They are very away. They are two different things. One is electropositive, one is electronegative. One gives and becomes stable, one takes and becomes stable. So this is electropositive and this is electronegative. Understood? So what they are going to do? Now they are going to combine together. From two different fields, they are coming together and one electron. And here Na plus Cl minus, Na plus Cl minus plus 1 electron. So electron in both side of reaction getting cancelled. So here it is coming Na plus Cl, NaCl, positive negative bind together, because always there is an attraction between positive and negative. And 100% this story is over here, and this is called as chemical reaction. Understood? So this is what the main basic format of chemical reaction. Every atom in the element wants to gain the nearest noble gas configuration. Okay, Manshu. So every atom in the element will try to gain the nearest noble gas configuration. So in that process, what they will do, they will either gain electron or they will lose electron. So in that process, what they are exactly going to do, they will be exactly either gaining electron or they will be giving electron. So in this process, we learned that sodium will give one electron to become like neon, and chlorine will take one electron to become like argon. So in this give and take, they are gaining stability. So in this give. So definitely when one is needing and one is giving, they both will join together to make a stable compound. And salt is the stable compound. I rest my case. And this is what is the story. Understood? This is what is the story of every chemical reaction. Of every chemical reaction, this is the story. So I hope everybody might have understood. So that's what is the element. atom is about. The atoms are exactly one of the part of the element, and all the different elements are having different type of atoms, but all the atoms had only one thing. They want to gain the nearest noble gas configuration. They want to become like the noble gases. Noble gases are stable gases, but the elements who are present in the other what you call periodic group number 1 to 17, they are not stable, they are unstable, and they really wish to become like 18th group. I hope everybody might have understood this part. In a very simple format I have explained this one. How is it? Tell me. So here, so an atom is the smallest particle of an element that takes part in chemical reaction and maintain its chemical identity. This is this. This chemical identity is most important. Yes. This is explanation. First, we need to explain this one. Na? So in absence of this, how I am going to show questions? So this part is only explanation. Now look here. Next part is, if you try to understand that atoms of element are different from those of any other element. Free atom except those of noble gases do not exist under normal condition. That's what. You need to understand this one. मैम चैट पढ़ लो मैम इसका इलेक्ट्रॉनिक कन्फिग्रेशन एस डी एफ या एस डी एफ रूल इज देयर एस डी 1:2 S2 2p6 3s2 3p6 4s2 3d10 that is SPDF rule, that is called as SPDF rule. Yes, that is called as SPDF rule. Yeah, degenerate orbitals, everything I know, sir. Which class what to teach, accordingly I am teaching. Yeah, S is called as spin. S orbital. First block and second block, yes. First is called as alkali, second is alkaline earth metals. And D block is called as transition elements. I don't need book here. Don't let them understand this. Yes, that's what is there now. So we can't scare them. They are the newcomers in class 9th. If you will scare them, means they will not study. So what is needed, according to that only, if we will teach, means then 100% will be having that affection for the subject. In KG1, class 1 student, we cannot teach class 10th concept. They will definitely hate studies after that. So 1 to 1, 2 to 2, 3 to 3, level wise. Wow. I am not a chemistry teacher. I am a mathematician. Misconcept. So now look at. So free atom except those of noble gases. So you need to understand that only only noble gases can exist in free state. In but what you call other element in the periodic table, they cannot exist in free state. Okay, so that they cannot be existing in the free state. Rather than that, everything कर रही है. So that is existing. So atomic size, we need to talk about the atomic size also. Understood? So here, hydrogen atom is the smallest. The radius of hydrogen atom is nearly very. So nano, that is 1 into 10 to the power minus 10 meter. That is 1 nanometer. 0.1 nanometer is the structure size. Okay, 0.1 nanometer is the structure size. That's also one of the most important thing we must not forget about. See, you need to understand another important points. Okay, I'm doing PhD. That's good only. Now look here. So when we are talking about the atom, you need to understand that atom, the entire mass of the atom is exactly concentrated in the nucleus. Understood? These are called as extra nuclear part. What it is called as, these sections are called as extra nuclear part, and this is exactly the nucleus part. I hope you might have understood. Yes, so this is exactly the atomic structure, and the entire mass of the atom is focused inside the nucleus, because inside nucleus proton and electron is there, and they are exactly binded by a charge. They are exactly binded by charge. Pi Meson source is there. So that also we need to study. So next class we are going to talk about, next class we are going to have discussion about these properties. Let's go back to the work. हैं. So previously, how they have given symbols and how atomic number, shortcut definitions, everything we are going to study in next class. So next class will be very, very interesting. Please join the next session and I will be explaining you about the atomic structure in much details. Electropositive and electronegative, everything I'm going to teach in the next class. Net is slow. Oh, sorry for that. So next class, I'm going to talk about everything. So now this it is still here only. Fine. Bye for now. Now class ninth. Now I'm having class with class 10. Soon I will be again online with class 10.